All right, today we are diving into a really big and honestly pretty challenging idea. It comes from the psychologist Robert Plomin, and his argument is this. Our DNA is the primary, the most important systematic force that makes us who we are. Now, I know that's a tough one to chew on, but it has some absolutely massive implications, especially if you're a teacher.
So, here's the plan for our journey today. First, we're going to tackle that classic nurture assumption, the idea we've all grown up with. Then, we'll get into how scientists actually untangle nature from nurture. After that, there's a huge plot twist. Seriously. Then we'll jump into the cutting-edge science of DNA itself. And finally, we'll bring it all home and ask, what does this actually mean for the classroom and for you and me?
All right, let's set the stage. For, most of the 20th century, the world of psychology was pretty much dominated by one big idea, environmentalism. And the core of it is pretty simple, right? It's the belief that we are what we learn, that our family, our upbringing, that's the key factor in shaping who we become.
And this idea, this nurture assumption, it wasn't just some academic theory. Nope. It became the absolute bedrock for pretty much everything. All the parenting books, all the educational theories, it was just the default. But that begs a really important question, doesn't it? What does the genetic evidence actually have to say about all this?
Okay, now this is where things get really fascinating. Look at the gap between what we think and what the science actually shows. We tend to believe something like breast cancer is super genetic, right? People guess around 53%. But the research? It's closer to 10% heritable. And then you flip it. Look at body weight. We guess maybe 40% is genetic. The reality? It's a whopping 70% heritable. Our intuitions are often way, way off.
So that leads to the million-dollar question. How on earth do scientists even begin to separate what's coming from our genes and what's coming from our environment? It sounds impossible. Well, let's look at the two classic and frankly brilliant methods they first used to crack this nut.
First up is the twin method, which is basically nature's own perfect little experiment. Think about it. You've got identical twins, who are, for all intents and purposes, genetic clones, 100% the same DNA. Then you have fraternal twins, who are just like any other siblings, sharing about 50% of their DNA. So the logic is simple. If a trait is way more similar in identical twins than it is in fraternal twins, well, that's a huge clue that genetics is playing a big role. Okay, and this brings us to a really crucial point. This term heritability is super easy to misunderstand. It is not about you as an individual. When we say body weight is 70% heritable, it doesn't mean that 70% of your personal weight comes from your genes. No, it means that 70% of the differences in weight we see across an entire population, why some people are heavier and some are lighter, can be traced back to differences in their genes.
All right, hang on to your hats, because this is where we get to one of the most mind-bending findings in this whole field. We all think of the environment as something external, right? Something that just happens to us. But what if that's not the whole story? What if our genes are actually, in a way, pulling the strings and influencing the very environments we end up in?
Okay, let's take a simple example. Something that feels 100% environmental. How much TV a kid watches. You'd think that's all about parental rules, right? Screen time limits, what's on in the house, pure nurture. But is it? Let's see what the research says.
Get this, it is absolutely wild. Genetic factors account for about a third of the differences in how much TV kids watch. A third! And it doesn't stop there. The same thing applies to so many other things we just assume are pure nurture, like what kind of friend group a teenager falls into. It's just astonishing.
And this is the absolute heart of what Plomin calls the nature of nurture. It's such a brilliant phrase. It means our genetic tendencies act like these little internal compasses or nudges that push us to select, to modify, and even to create environments that fit our natural inclinations. The example about reading is perfect. A kid who is genetically wired to be curious about books is going to pester their parents for more stories, go to the library. They actively help build their own book-filled world.
Now, for a long time, all this evidence was, a bit indirect. It was based on these really clever but inferential studies of twins and adopted kids. But now we're in a whole new ballgame. The DNA revolution means we can stop guessing and start reading the genetic blueprint directly. This changes everything.
I mean, think about this incredible journey we've been on, from Gregor Mendel and his pea plants back in the 1800s, all the way to mapping the entire human genome. It's been a long road, but it has led us to this unbelievably powerful new tool called the polygenic score.
So what in the world is a polygenic score? Honestly, the best analogy is to think of it like a personality test. You know how those tests ask you a bunch of questions to build a profile of, say, how shy you are? Well, a polygenic score does the same thing, but instead of questions, it's reading thousands and thousands of tiny markers in your DNA. It tallies them all up to create one single score that predicts your genetic leaning for a certain trait.
And let's be super clear here. We are not talking about finding a single gene for being good at math or a gene for being an extrovert. That's not how it works. We are looking at the combined cumulative effect of thousands, sometimes tens of thousands of tiny genetic differences. Each one on its own is just a whisper, barely detectable. But when you add all those whispers together, you get a surprisingly loud and powerful prediction.
Okay, so let's bring this back to the real world. What on earth does all of this mean for you, standing in front of a classroom of 30 different kids? This is where this science really hits home, and it has some truly profound implications for how we even think about the whole enterprise of education.
Now, here's an idea that might feel a little backward at first, so stick with me. In a strange way, you can think of heritability as a measure of fairness or meritocracy. Think about it. If we do our jobs as a society and create truly equal opportunities for every student, if we remove all those environmental hurdles, then what's left? The differences we'll still see in how students achieve will be more, not less, due to their underlying genetic makeup.
And right away, I'm sure a big red flag is going up for a lot of you. This is the big worry, right? If things like school achievement are so heritable, does that mean we're heading for some kind of genetic caste system, a society divided up by DNA?
Well, the science actually suggests no, and there are a couple of really powerful reasons why. First, you have what's called the genetic lottery. Every parent passes on a random half of their genes, so the deck is constantly being reshuffled. This also leads to something called regression to the mean, which just means that kids of really exceptional parents tend to be a bit closer to the average. And because of that reshuffling, most of the highest achieving kids in any generation actually come from average achieving parents, just because there are so many more of them. On top of all that, there's just plain old random chance, all the unpredictable stuff in life that shapes us. All of this keeps the system fluid and allows for social mobility.
Okay, and this brings us to what I think is the most important takeaway of all. It is so easy to hear all this and start to feel like we're just puppets and our DNA is pulling the strings. But that, Plomin argues, is a complete misunderstanding of what the science is saying. Here's the critical distinction we have to make. Genetics is about influence, not determinism. It's not about fate. Your genes don't hand you a script and say, this is your life. They're more like whispers or nudges. They create propensities, not predestination. And that's actually an empowering idea, right? Because if you know where you're being nudged, you can choose how to respond.
And this really reframes the job of a parent or a teacher, doesn't it? It suggests that our goal shouldn't be to try and mold a child into something they're not, to try and rewrite their blueprint. Instead, our job is to be the best possible architect for them, to look at their unique blueprint and provide the best materials, the best support, and the best conditions for them to build the most amazing life they possibly can.
So let's end with this question to think about. What if this new science doesn't make teachers less important? What if it makes them more important, but in a different way? What if our goal isn't to make every child the same, but to become experts at recognizing and respecting their genetic differences and then helping each one become the absolute best version of who they were meant to be?